Taking a closer look at the LJ Create EV Batteries and Charging Panel Trainer. Our EV Batteries and Charging Panel Trainer is designed to investigate the following. Number 1. The structure of an HV battery. Number 2. External effects on an HV battery. Number 3. Cell balancing. Number 4. Troubleshooting.
Taking a closer look at the structure of an HV battery.
The EV Batteries and Charging Trainer teaches students about the construction and operation of an HV battery pack based on a 400-volt architecture. The battery pack consists of 8 modules connected in series, each with a 50-volt nominal output. Each module contains 12 4.2-volt cell packs connected in series, with each cell pack made up of 8 cells connected in parallel. Measurements can be taken of each cell module, and the cell packs of one module, and are scaled appropriately to ensure students can measure voltages safely, then apply the displayed multiplier to obtain the real vehicle voltage. A short of the HV battery to the chassis of the vehicle will be detected by the isolation monitor. This will disable the HV system, representing the actions of a real vehicle. The HV system is also disabled by disconnecting the service disconnect, or first responder loop. A service disconnect, disabling the HV battery itself, is also available, leaving the individual modules available for testing and measurement.
Taking a closer look at the external effects on an HV battery.
The EV Batteries and Charging Trainer makes it possible to monitor the effect of external factors on the battery, such as load and temperature. By selecting drive mode, a cruising speed can be set, and the system's performance monitored during the acceleration, cruising, and deceleration phases. While driving, the current draw on the battery pack can be monitored on screen, measured at the current sensor test point, or visually observed with the power flow display. The real-time efficiency of the HV battery can be displayed on screen, and is also measurable by monitoring the battery's voltage drop. The temperature of the HV battery can be varied, which results in a change in the efficiency of the battery. The EV Batteries and Charging Trainer simulates the active temperature management that takes place in most EV batteries, with color indicators to show heated or cooled coolant flow. The parameters of the battery can be monitored whilst charging, with both an AC or DC input. With the students being able to follow what is happening within the onboard AC charger, using the panel schematic graphic. In battery test mode, the battery can be tested under workshop conditions as if it had been removed from the vehicle. This includes setting specific parameters such as temperature, health of the battery, state of charge, and current load or rate of charge. This allows students to analyze the effect of each parameter in isolation, and build their understanding of how each factor has an impact on another.
Taking a closer look at the principles of cell balancing.
As an EV battery goes through a number of discharge and recharge cycles, the cells will naturally become unbalanced. This can be monitored on the second module of the EV Batteries and Charging Trainer. A visual representation of which cells are low or high, relative to each other, updates in real time while the panel is being operated. The lowest, highest, and median cell values can be monitored both as voltage values and the current state of charge. When performing an AC charge to 100% capacity, passive cell balancing can be observed.
Taking a closer look at troubleshooting an HV battery.
Instructors have a passcode to open the fault insertion panel. 16 faults are available, covering all blocks of the EV battery system. The fault insertion panel provides optional descriptions of each fault. Multiple faults can be inserted at the same time. The troubleshooting process starts with the virtual scan tool. If the system has multiple problems, the codes are listed so that the learner can step through them. Learners then turn to a multimeter or scope to confirm the faulty component. Following a period of learner practice, instructors can insert a number of faults, lock the insertion panel, then leave the learner to list out the faulty components as an authentic assessment activity. If you have received your panel, we're here to help you integrate it into your program. If you would like to order a panel, please contact us for more information.